Let me know when you can see my screen. I have just started sharing.
Yeah, we can see your screen there.
Right. Okay. So, middleware. Before I go ahead and start speaking, whoever is there in the call, can you tell me in just one-liner if you have any understanding or any thoughts about what is middleware? Hello? When you hear the term middleware, what bell does it ring?
Web administration.
Okay. Anything else? Well, as you rightly said, yes, it is web administration, but it is not just only web administration. Now, before I get into a traditional way of defining things, let us look at a few interesting graphics. So, this is the world where we live today. It's also called Web 2.0. We have wikis, we have websites, browsers, applications, links, social media, data everywhere, softwares at the tip of our finger, right? This is what our digital world looks like. And some of you might be knowing about this term Web 2.0. It is as it is currently known as. Now, this didn't happen just yesterday. Okay, there is a very painful and long history behind it. It all started in 1961 when the first packet switching paper was published, and people actually came to know that they can transmit data in the form of small packets over cable between two connected devices. So since that knowledge came to us, we were able to make two devices sitting on different geographical locations talk to each other, and that's how it all started. But it painfully took 24 years for web to take birth. The first website to see the light of the day, it took 24 years, and another 6 years for middleware to come into a shape. If you look at this small piece of info on the top, on the left side, you'll see, if you calculate, it's like 30 years from the time the first effort started in history, middleware became a reality. Now, as we saw in the first graphics, we now have Web 2.0. Now that has also become a history. In 2006, the web administrators realized that whatever we started with 10 years back or 15 years back, that has dramatically changed. And back then, there was nothing called Web 1.0. In 1991, the first time the World Wide Web, this term was coined. This term came into public. And it took another 5 years to formalize everything, what is web. Okay, and at that one point of time, we had 250,000 websites across the globe. Most of the content was like, it's a one-way traffic. The web admins or the web developers used to publish info or like text or graphics on the websites, and the users used to just go and use it, like read it, or if possible download it. There was no communication from the other side, like the user community giving back to the website. And these 10 years, from 1996 to 2006, everything changed. If you look at the graphics, the amount of involvement of users, amount of user-generated content became a significant part of the World Wide Web. And near about 80 lakh websites were officially registered by 2006. So you can see the magnification. Now, why this new version of web had to come into picture? Because the nature of what we see web today is quite different from where it started. Web is now intelligent. It can think on behalf of us, right? It can harvest information and deliver insights from those harvested information. So it needed a new formalization, and that's when the Web 2.0 term was coined. And the World Wide Web Consortium, that's the body which decides on all of this, they thought that, okay, let us coin the previous version when we initially formalized web in 1996 as Web 1.0. So actually the name Web 1.0 came later. So now basically from 2016, some of you might be aware, we have moved to Web 3.0. Because, and this is how Web 3.0 looks like. We have intelligent search engines. Even before we think of the keyword, our search engines suggest, okay, this could be the possible keywords. Go ahead and use them. We have three-dimensional games on our laptops or desktops. We have virtual intelligent tutoring systems. We have virtual encyclopedia. Now, if you notice on the left side, the user-generated content is becoming more than the admin-generated content. Because if you might be aware about blogs and the social media as a whole, and if you notice in social media, the actual web admin does not do much. It's the users who create the content. And if you look at the very famous example, Facebook, the Facebook admin might have created the website, but the content is being generated every day, every second by the users like you and me. That's the biggest difference between the web, how it started, and web, what is now today. And if you look at the number of sites which are officially registered, it's crossed even the number of people on this globe, probably in some countries. It's 8 billion plus. And if IP version 6 becomes a reality, every device on this planet can have a website for itself. So you can imagine the amount of data it will generate. So this is where we are moving. So on the right-hand side, you can see a small glimpse of the evolution. So initially, web was only about publication. I have some content, I'm publishing that. And the next came the interactive web, where users used to give back to the website via the content they are generating. And the next generation where we are moving to is the Internet of Things, smart city, and those kind of things, where website will be so intelligent you might not even need an operating system to run on your machine, to run on your laptop. Everything can be done via a browser. And what lies behind the browser is the World Wide Web, right? So having said that, let's try to define what is middleware. Now, okay, now how did this web and middleware fit together or sit together? Now, web is just a part of the middleware. Middleware is what connects all these devices. If you notice from Web 2.0, each and everything is connected. They are not isolated to each other. Your browser and website and links and content, social media, data, everything is connected to each other. You can't imagine or use anything without the other. So middleware basically connects these dots, these different connected devices, which are formerly known as World Wide Web. Middleware actually does the job of connecting those dots. You might be thinking, okay, what the hell is this? I know network connects everything. Yes, of course, network connects everything, but imagine you just go to google.com and you type in a search keyword, and instead of getting a page with the search results, you just see some connected network devices jumping on your screen. Would that make any sense to you? No. So in order to make sense out of these connected devices, middleware comes into picture. It gives a sense of direction, a sense of these connected devices. So coming back to where middleware and web sit with each other, a website is just a subset of what middleware is. This entire game is, if you call it middleware, website is just a small subset of that. Right? So what we see on our browser is just a front layer of it. The main thing is happening behind the scenes, which the user can't even see. Okay, but it's happening at the split second of time. So let's now try to define middleware in a formal way. It's a family of software that connects various software components or enterprise application to provide a concurrent and or distributed service. What I mean by concurrent is like you get the service at the same time from multiple locations. Okay, and what I mean distributed is you can have a single service, and it's a imagine it's a heavy service which can't be given from one server. You can actually spread out the service across multiple servers, and in a distributed way you can give it to the user. Okay, so it is a layer, a software layer, which lies between the operating system and the business application. Say for example Facebook. Facebook is a application, is a business application. Okay, behind the Facebook page which you see, there lies the layer which is the middleware layer, which makes Facebook available to the users. Okay, and that software layer is sitting on the operating system, on the server on which it is hosted. Okay, now typically middleware, the domain middleware, it involves business applications, web applications, websites, multi-tiered web applications, message publishing software, automation software, provisioning software, identity management software, etc. If you imagine middleware if you imagine the IT infrastructure like a body, then middleware is the nervous system along with the logical part of the brain. So if you can visualize in that way, it might be easier for you to understand where middleware sits in our life. Okay, so let's proceed. So these are a glimpse of some of the technologies which is included inside middleware domain, some products and their vendors. The most important and commonly used technology in middleware is a web server and an application server. Okay, I'll come into a detailed definition or what it is a little later. In the web server category, we have the maximum number of vendors. The most notable among them is the Apache HTTPD software, which is a product of the Apache Software Foundation. By the way, it's absolutely free of cost, open source, and it controls about 50% or more of the market share. The next in line is the IaaS or Internet Information Services from Microsoft Corporation, serves almost 30% of the market. The next in line is Nginx, which is the newest one of Russian origin and covers about 10% of the market. The remaining is shared between some of these Oracle, IBM and iPlanet products and various other small vendors. The next in line of importance and very critical is application server. The major or the notable vendors are Red Hat, JBoss, or the JBoss community GA. It's like two versions of JBoss, one from the open source community, one from the Red Hat vendor. Then you have Apache Tomcat, then WebLogic, which is an Oracle product, WebSphere, an IBM product, and a few more. Typically, IaaS is considered both a web server and an application server, right? Then we have a category of technology which is called a forward proxy server or reverse proxy server, and most of these web servers are used as a forward proxy or reverse proxy. Okay, these products like Apache HTTPD, it can either be used as a web server which serves something to the user, or it can be used as a reverse proxy or forward proxy. I'll come to this explanation later on. Then we have FTP servers. Again, most of the OS servers can be used as an FTP service provider. Then we have a category of products which are called application integration server. Their basic job is to integrate different dissimilar systems. Okay. Then we have authentication server and policy server, very important. And for example, in HP, or as rather in DXC, we use SiteMinder. It is an authentication server or policy server included in the middleware domain. Then we have software load balancers and firewalls, for example, BigIP. And we have content delivery systems like the very popular ones like WordPress, Drupal. People who are into blogging, you might have heard about WordPress a lot, right? Then we have DNS or LDAP. The most important ones are the bind, which comes from Unix, the Microsoft DNS, and OpenLDAP. Then we have a few more types of software like automation software, commerce software, service-oriented architecture. So as I said, this list is not the entire thing. This is just a part of the various technologies which are used in middleware. If you notice one thing, the basic job which these technologies do is serve some kind of request and give some kind of response, and it connects different things, right? And there is one critical piece of technology which is being used. It's just hidden in this lower left corner. It's called SSL. The important product which is used is OpenSSL. It is used for encryption. Although encryption is a security, is part of security, but it is extensively used in middleware. There's very simple reason being middleware connects one point to the other. So unless and until the channel is secured, there is no point of having these technologies being used by the users. So moving ahead to the customer. Now we are only in the support business, right? So to the customer, how does middleware appear, right? The business applications which the customer uses, sitting behind them, the first and primary thing is the middleware layer, and sitting behind them are the other things like database, operating system, and network. For the customer, he only sees the business application. He does not see the layer behind. And the layer behind looks something like this. So at the topmost layer, which you see, layer 6, this is what the users or the enterprise users or our customers see, the business application. The very next layer behind it is the middleware layer. And then behind that is the database. And then behind that is the platform, backup and storage. Behind that is the network, and behind that is the data center, right? So I use this analogy very often. So data center and network are like the skeleton of a human body. The muscles comprise the platform part. The database is the memory part of the brain, and the middleware, as I said before, is the nerves which connects each and every corner of the body, and the logical part which thinks. And business application is actually the entire body. Interestingly, I have mentioned middleware twice, one as a layer 4.5 and the other as a layer 5. It's because there are some applications which do not need a database. They just process business logic. So they can directly sit on top of the platform and serve the business application. They don't need a database behind it. And some applications sit in front of a database and use the database for its purpose. So that's why middleware either would be considered in a layer 4 or it will be considered in layer 5. Okay. So let's move on. So why did we need a middleware layer at all? So as I said, in 1985, web was born. The first website which was registered is in 1985, and it's called, I think I just missed the name. Yeah, symbolics.com. It still exists, surprisingly. And in 1991, and after 6 years from the first website was registered, middleware came into picture. So why do we need middleware? Now let us try to understand that. If it's a single user and a single client application, and there is one server which holds the entire resource. When I mean resource is business application and or data. Then we don't need middleware because I can just type in the IP address of the resource and get what I want, right? But if I have multiple users who are using a single client application or multiple client application, but they're using the same resource, then also we don't need middleware. But there is a high chance of conflict, like the same resource being accessed by two different people from two different systems at the same time will definitely create a conflict. But in both these cases, even if you don't have a middleware layer, I can still access it over the network using IP address or whatever way. But the problem happens when we have a situation like this. If we have multiple users and if we and multiple clients and each access the resource independently, like user 1 does not care whether user 2 is accessing the resource or not, he just wants to access. So it's like two parallel connections coming to the same resource. So you need something to control it. Okay, so you need some mechanism to decide who gets the resource and when. And the situation becomes even worse when you have the resource spread across multiple servers, as you can see on the right hand side. These are the servers where the resources are spread across. And if we allow these multiple users and clients to just access them, definitely it's not going to work. Nobody is there to control and tell, okay, this user 1 goes to server 1, this user 2 goes to server 3, and so on. So again, we need a controlling mechanism which will decide who gets what and how he gets what he needs. So that's where the web servers and application servers comes to picture, and that comprises middleware. Okay, so it's purely the need of how the resource should be accessed over the network is where the middleware layer comes handy. So as I said, middleware controls who gets what and who does what in a request response ecosystem, and this is very vital factor. So what we see here is like the agents on the left hand side is placing a request on the agents on the right hand side, and the agents on the right hand side are giving back a response to those requests placed by the agents on the left hand side. So users placing a request to the servers where the resource sits, the servers give back a response to the users from where the request came, right? So this is called a request response ecosystem. And in a request response ecosystem, it is very important to control these 2 points: who gets what and who does what. So the user 1 on the left hand side is supposed to get a resource from server 1. If his request lands in server 5, he will not get the desired response back. Similarly, user number 5, whose request was supposed to go to server 2, if it lands up in server 7, he is not going to get the right response back. So that's where comes into picture these two phrases: who gets, the user gets what he has requested for, and which server does what part of the job is decided by who does what. Now, why this is vital? We have only considered this many requests and this many servers, but the reality today is something like this. We have thousands of application users, probably devices, billions of users, hundreds of applications, okay, and we have miles and miles of data centers from where these are being served. So unless and until, and this entire traffic of request from the left hand side passes to the resource pool on the right hand side over the internet. Okay, by using the various kinds of network topology, by using the LDAP servers, DNS servers, you name it. Unless and until there is something who controls this entire game, neither of the requests coming from the left would reach the right resource on the right hand side, nor the right response from the resources would go back and reach the right user from where the request came. So that's why we need middleware, a controlling mechanism. Okay, so that re-establishes our baseline that middleware connects the dots. So I have actually borrowed this definition from IBM. Middleware provides an enabling layer and an enterprise integration, which is needed to connect our mobiles, laptops, workstation, also known as systems of engagement, with the systems of record, like the application, the database, and all that. And what is the purpose of doing all that? We are trying to derive a business value of the information which we have, thus yielding systems of insight. Okay, so anyone has any question, or otherwise I'll move on. Hello?
Dave,
Okay,
just for my
I'll take it as
curiosity,
take it as, yeah.
Dave, just for my curiosity, I would like to know what are the common issues you come across in day to day in related to web.
Resource not available. What is my purpose of middleware? To make these resources available to the requests. Right? So if a resource is not available for whatever be the reason, be it network, be it the resource itself, or be it a request which was lost, the user will not be able to see the response back. He is waiting for the response. He has placed a request, but he is waiting for the response. And for some reason, in the section in the middle and the section in the right, the response does not go back to him. That's the problem. So in simple terms, that's the only issue. Now, why that is happening? Either you have to dig into the layer here in the middle.
Your PC. We lost you.
I think there seems to be some issue in the Skype. It disconnected for most of them.
Hello.
Yeah, your PC
Yeah,
is
they.
rebooted.
Is it back now?
No.
Yeah, back.
No, we're not
It
able
is
to
still.
see.
One sec. Skype is frozen. Just a second. Really sorry. Come on.
No, no. Are you there?
I am there, but for some reason the sharing is not working. Just give me a minute.
Okay.
Just let me know when you can see again.
Yeah, your screen is loading now.
Okay, so Suresh, I don't know where I got disconnected. So, were you able to hear my answer, or I got disconnected
Yeah,
before
you
that?
said that most common issue is resource not available.
Yes. Yeah. The whole purpose of having middleware is to make these resources to be available to the requests, right? So, and if you think there is no other purpose of having middleware at all, right? So if for any reason, even if it is for the layer in the middle or the layer on the right, the resource is not reaching to the user who has placed the request, that's an issue. That's the only problem, right? So my search is not working, or mail is not working, or Google is not working. That means the resource wherever it is hosted in the internet has not reached back to the user. That's the only issue. So if we solve that, if I solve that, middleware is working perfectly. Okay, did I answer you?
Yeah, Dev. Thank you.
Okay, no problem. So now we'll try to understand three important technologies being used in middleware. As I said, web server, application server, and reverse proxy and forward proxy. Okay, web server, uh, as we know, it's a request response system, right? So web server basically does four types of job. It creates a request and response between two users, between a user and a server, between two servers, and a server and a user. Okay. Let me give some examples. So you are chatting with somebody, right? So here the request, and you're getting a response from the other person whom you're chatting with. So here it's a request and response are coming from two users, right? Just forget about what is happening at the back end. So for both the agents, both the users, whenever they are interacting, they are either sending a request and getting a response, or vice versa. Now I have my a user is requesting something from a server, say he's browsing Flipkart and is trying to get info from a server. So his request first lands on the web server, and he gets a response back from the server. Imagine that server where the request landed did not have the sufficient info, so he had to request to another server and get the response from that second server and give it back to the user. That's where the server-server communication request response comes into picture. And in the third case, when it's an interactive situation, I place a request, the server, while processing that request, finds that I need an info back from the user. He sends a prompt back to us. We select yes, no, or check a box or check a radio button, and the response goes back to the server, and the server gives a response back. That's where the last example comes into picture, server and user, where the server is placing the request and user is giving the response. So web server, it is usually a very lightweight application which sits on top of a operating system. Its only job is to receive requests and serve responses. Okay, typically it listens on port 80 and port 443. Port 80 is for an unsecured connection, and port 443 is for secured connection. It can serve static web content, the normal text and image based pages. It cannot serve dynamic web content. For dynamic content, it needs to take the help of other technologies sitting on top of it, like JavaScript or PHP or Python, Selenium, CGI. Okay, so if these technologies are sitting on top of a web server, then the web server would be able to serve dynamic content where there is some kind of interaction. User selects something or puts in some input in a text box, submits that, and gets a response back. This job is not done by the web server actually. It's done by the technologies sitting on top of it, like JavaScript or PHP or Python. But we don't need an additional server. The web server is capable of doing that. To explain more, let us look at the graphics on the right. So user uses a browser, okay, serves via the IP address, it tries to connect to a web server, okay, and he gets a response back. Now, if the information which is requested by the user is a static page, like some text or graphics, the web server directly can give it back. On the same web server, from the same web server, if I want a dynamic content back, like an interactive web page or something like that, I need to have some other middleware technologies like JavaScript, PHP, and Python, which will sit on the same box, okay, but it will read the response from the user, read the request from the user, which are dynamic in nature, and serves the response back to the user using the same web server. I don't need an additional box for that, okay. Now it is very suitable for load balancing and reverse proxy capabilities. So web server can do the job of load balancing also, and we will see it a little later, an example. It serves as a gateway for business applications, which is hosted independently on top of application servers. So business applications are the ones which the customer uses, which the customer sees at the end, okay. Now it can either be sitting on another application server and the web server just behaves as a gateway to that, or it can be sitting independently on some server, and in that case also the web server just behaves as a gateway to that, okay. Usually it supports the extensions like HTML, HTM, ASPX, ASP, PHP, JS, etc. So, and it usually supports 4 types of protocols: HTTP, HTTPS, FTP, SFTP. There are few more. These are the major ones. Okay. It can support business logic, which is processed by the web applications sitting on top of it at a web layer. Now, as I said before, the dynamic content, if it has to be supported from web server, it needs to come from technologies like PHP or JavaScript. Now, these actually process the business logic, and the web server just passes it back to the user. So its basic job still remains the same. It's receive request and serve responses. Okay. Now there are 3 scenarios which are given in the right side. So here in the first scenario, we have a browser and there is a web server, and I know the server's address, the server's IP address. I can access it via an IP address. I don't need any name resolution for that. Okay. In the second scenario, I have the URL of that particular server. I don't have the IP address. So in that case, a name resolution is needed. So a DNS server would serve the purpose. So the DNS will resolve the name to IP, and the user will be able to connect to that web server and get the response back. And the third scenario, where I have 2 different websites and they are sitting probably somewhere in the internet, and I only need to have information about the web server which is sitting in front of it. As I said, it behaves as a gateway. Okay. Now here in this case, the name resolution is the only way to get the response for or use these website 1 and website 2. So in all these cases, if you notice, the web server either serves the response or behaves as a gateway. Okay. So that's the only job of web server. Now there is another specific, very important job of web server, which is behaving as a proxy server, both as a forward proxy and reverse proxy. Okay. Now let me explain what the proxy, the forward and reverse proxy is. So typically it happens like this. I have a web server and I have some server sitting behind it where the actual website is hosted or the actual business content
Dave,
is hosted. Yeah.
I think somebody was interrupting. Is that Balaji?
It was me. They
Yeah,
just wanted
Balaji.
to. Can you give me an example for that last one? Practical example in the previous slide.
So one sec. I don't know, my Skype is behaving. Okay, yeah. This one,
So
Balaji, the last one.
Can you give me a practical example to
Yeah,
understand better?
sure. This one where I mentioned website 1 and website 2, right? Right. Okay. So let's take the example of google.com. So if you have noticed, when we from India, when we type in google.com, many a times it gets redirected to google.co.in. Right? So google.com and .co.in are not the same. And there are sites like google.co.uk or .cn, which is specific for India, China and UK. So imagine website 1 and I was giving you a wrong example. Imagine the same google.com, and we have two data centers of Google in India, right? One in Hyderabad and the other one probably in Bangalore. So, and google.com, when we type in the browser, it translates sometimes to google.co.in, right? So the same .co.in page sits in two geographical locations, right? In Hyderabad data center as well as in Bangalore data center. I don't need to know the IP address of them. I don't need to know the direct address of them. All I need to know is the URL, google.com, which hits the web server sitting in the middle. It is this web server which knows where the resource actually lies. It's the same resource but running from two different places. Okay. So if you remember, I told that middleware serves the responses concurrently, okay, and in a distributed manner. So here, the same website, if the website 1 in Hyderabad and website 1 in Bangalore are not concurrent, they will give me different responses to a particular request sent to them, right? So they work concurrently. Middleware makes sure that they will work concurrently and in a distributed manner. So this web server only over here actually behaves as a proxy server, reverse proxy, which I'll see in the next show you in the next slide, and the gateway.
Yeah, that's got it. Thank you.
Okay, all right. So typically, when like in the previous example, I was mentioning two different geographical locations where my resource is sitting, resource in the sense application and data, and I don't want to reveal that particular geographical location's IP address or server name or whatever. Okay, so I just give the primary URL to the end user, for example google.com. So user does not need to know, or I don't, as a web admin, I don't want to reveal the internal host name or IP address from where the response is actually going. So that's where a proxy server comes into picture. Now there are two types of proxying. One is a one-way proxying, which is called forward proxy, and the other one is a reverse proxy, which is two-way proxying. Now, in case of a forward proxy, what happens? For example, we type in www.example.com/myapa, some application. It comes back to the user either in the form www.myapa.com/example folder/example page.dsp. Now, just notice the red font over here. I have revealed the folder where it is sitting. It is a piece of info which should not be visible to the end user. Okay, but that got exposed because when the response went back, it went back with the info of the backend. because it was only a forward proxy. Like the requests coming into the server was proxied, but the response going back to the user was not proxied. It can also, in worst case scenario, it can also reveal the server name. It can go back as https://server1.myapa.example.com/example folder/example page.jsp. So if the response goes back like this, I have revealed my server info, I have revealed the folder where the info is lying, and everything. To overcome this drawback, reverse proxy came into picture, where it proxies both the ways. So if I put in the same example .com/myapa, it will come back as either example.com myapa/example page.jsp, exactly what the user had requested for, or even more protected sites will just give you back what you had typed in, www.example.com/myapa, but in the page you will see only the response which you wanted to get. Okay, so architecturally it works this way. In case of a forward proxy, you have the browser, and then you have that forward proxy server, which is nothing but a web server where it is only configured as a forward proxy, and behind that you have these three servers where the websites are sitting. Okay, now in case of a reverse proxy, you have a user which is connected to the internet, places a response via its browser, and you have a reverse proxy server. It is, as I said, it's a simple web server configured as a reverse proxy, and you have two origin servers, 1 and 2. When the response goes back, it goes back via the same path, same route, comes back to the user's browser, and it will show up only the address either like myapa or myapa/example page.jsp. It will not reveal the server name or any of the other internal resources. Okay, a little more elaborate example would be something like the one below. So you send an HTTP request from the user's browser via the internet. It goes to the web server, and then it goes to the server farm, which is sitting behind it, the hidden one, and the response comes back to the same web server, which is behaving as a reverse proxy. It just passes it back as an HTML response back to the user's browser. Okay, so my internal resources are safe, they are not visible, but yet my purpose is solved. The user got the response back for the request it had placed. So now let's come to to another very critical component of middleware, which is application server. It's typically a heavyweight software application which sits on top of the operating system. Now its job is to receive the request from web server, process it as per the business logic of the application, and serves the response back to the web server. Now the point to be noted is that the application server is not directly interacting with the end user. What it interacts is only with the web server, beyond which it's not its visibility and it's not its responsibility to know whether the response went back to the user or not. It's the responsibility of the web server to make sure the response comes back to the actual user. But the application server's scope and responsibility lies limited to that. Okay. Yes, to do the processing of the business logic, it will do whatever is needed. But once it has sent the response back to the web server, its scope ends there. Unlike web server, an application server can listen on any port, which is highly customizable. I can set up any port number apart from the 0 to 124, which is reserved. So starting from 1025 to whatever the operating system supports, I can set any port number where the application server will listen, and this is a big advantage. So I can put any number of application servers instances in a single box, and it can give different port numbers. It's just I have to configure that inside the web server so that the communication happens. It processes the business logic which is embedded inside the web application it hosts. So if you remember the first at the beginning, we went through a stack diagram where the layer 6 was the customer's application, the business application. So that business application actually sits on top of the application server, and whatever business logic is present inside that application, the application server helps to run that. Okay, so those business application is served to the end user via the web server, which behaves as a gateway. Now, most application servers are written either in Java or .NET. Now, .NET in the .NET world, we have only two primarily, IIS and BizTalk. Rest all the application servers are written in Java mostly. It supports Java-based and .NET-based business applications as well. And nowadays, there are application servers which are coming up which supports even more languages like Go and all that. But I mean, in terms of numbers, these are the major ones. Now, an application server can talk to another application server and a database or other types of middleware applications and non-middleware applications also. This is very important. Web server usually is not does not have this capability. Web server loaded with other technologies like JavaScript and Python or PHP can do this job of talking to another middleware application, but only web server, it's not possible. But that is possible by an application server, where it can talk to another application server or a database or non-middleware applications also. Now, typically the business application which is sitting inside the application server, that does the communication with the non-middleware applications, okay, based on whatever logic is written inside it. All right, and the application server's internal architecture is usually very complex. I have given one small example over here. It is from WebSphere. Typically, a single unit of WebSphere looks logically something like this inside. It has different types of management mbeans. So one administration node which is also an mbean, and one 4 execution units. I mean, this is very overview of a very simple example of a WebSphere single cell. Okay, now a particular WebSphere application server can have multiple cells like this, and those cells interact within each other. So the whole thing becomes very complex for an application server, and that's the reason why it is capable of processing the business logic. So this complex internal architecture gives that power to an application server to do that job. Okay, so let's look at the graphics. So a browser, I mean typically a user's machine, he sends a normal HTTP request to a web server, and there are various protocols the application servers usually support. Okay, it's not just only HTTP, HTTPS, or FTP, NSFTP like web server does. So one such protocol is Jolt. So there are others like T3 and all that. So internally, an application server can have a protocol defined for itself also. There are servers like that. And then an application server can talk to a database and get the data back, process it further, gives a response back to the web server, and that goes back to the user. And in the second example, we have an application server which is talking to not only a database but some other backend services, which I said non-middleware applications, and that application server will handle those communication. The web server will not come into picture. So until and unless the processing is completed, the application server will hold the control. Once it has finalized a response, it will send it back to the web server to be further forwarded to the user's browser. And that's how an application server works. Okay, so any questions? Otherwise, I'll proceed. Yeah. Sorry, Manu, can you repeat?
Any example of second scenario?
Yes. Okay. let us take okay, so you have Flipkart, right? Where we buy products, and Flipkart does not have a courier service of its own. It usually takes there is another vendor called eCart services. So imagine I have raised a request to buy a certain product, and it goes and sits in the application server, and I get the info from the database of Flipkart, but whether or not a particular area, if you give the pin code to Flipkart, it can search and say whether that particular product is available in that area or not, right? So those info will typically sit with the vendor who provides the courier service, in our example eCart. So imagine this other backend service is a server or a database from eCart. So this application server of Facebook contacts that eCart server, gets the validation with the pin code number which you have entered, and checks and says, okay, this product is available over there, gives the response back via web server back to you.
Yeah. Yeah, good example, Dave. Understood.
Okay.
Thank you.
Thank you. Okay, welcome. So, all right. So these are the use cases where middleware is used: small and simple web, and overall a networked application. Typically a two-tier where you have a user layer and backend layer. Big and complex web applications or networked application. Now, if you notice, I've mentioned and/or networked application. It does not necessarily have to be a website. It can be a network application. For example, we use this HPSM client, right, which is the non-browser version. Now, HPSM client is sitting on our laptop, okay, but it's a network application. It has a database in the back end. And how does it connect to it? It's not connected via one physical cable. It goes via a bunch of different other network components, some web server, some application server, and gets the ticket info back to me. So those are examples of networked application. It might not be a website, but it's still using everything which is there in middleware. And then we have large and advanced websites or network application, which actually, for example, where we have the recommendation system, like you or intelligent searches. In Web 3.0, we have websites, search engines, which give us suggestions of the keywords even before we type them, right? So those are the advanced web applications. Now we have email system. Three kinds of email system typically use middleware extensively. One is POP, one is IMAP, and the other one is RPC over HTTP. These three email system use middleware. Then we have the entire backend for our mobile applications. We have the entire cloud technology, DevOps technology, and Internet of Things. These are all use cases of middleware. You'll be surprised to know that the rapid development of JavaScript was behind fueling the cloud technology to that popularity what we see today. The entire interface of cloud technology is primarily built with three coding languages. One is Go, one is JavaScript, and the other one is Python. And what we see on our laptop screen goes back to a web server, and then goes back to an application server, and then goes back to some other systems which might not be related to middleware, but the communication still happens. The dots are still connected via middleware. So let's try to understand a simple use case, which is a non-enterprise example, like a simple user sitting at home and accessing a resource which is there in the internet. So the requests come like a data packet over the network, okay? So the flow in the red is the request coming from the user. It reaches the internet service provider of the user, and then the internet service provider checks with the DNS box. This is a very high top level example. I have not got into much details for the sake of time. Now this DNS server gives the info back to the internet service provider about the IP address where the resource is lying, so that internet service provider then goes through a myriad network of network components and reaches the service provider of the resource. And from there, the request finally reaches the server where the application or the data is sitting. And the response comes back as data packets over the network. So it goes to the internet service provider of that particular server. Then in the same way, it checks with the DNS box where the user is, okay, and it passes the response back to the network components, which comes to the internet service provider of the user, and finally it reaches back to the user. Right? So typically this is how a simple request goes and a response comes from the user to a server sitting at the back end. Now this same thing, when we consider in an enterprise example, where like in our case where we are sitting inside an enterprise, looks something like this. So users and customers are in different geographical locations. They send their requests, and this request come from via different network components, internet service providers, via the DNS servers and all that, and hits the perimeter of the enterprise, where typically it hits a perimeter firewall, and which checks with an internal DNS, okay, this is the request where it should be sent. Then it goes to an internal firewall, and from there it first lands up to a web server, which listens on port 80 and port 443. If it's an unencrypted request, it comes to port 80, and an encrypted request comes on port 443. That web server in its turn contacts the application server where that request should go, and that application server would either contact a database or process the logic and send the response back, or might contact another application server, get its job done, and then the response goes back to the the web server, and follows the same way back to the user. Comes to the firewall, goes to the perimeter firewall, goes via the World Wide Web, comes back to the customer or the user from where it originated. Okay, so now let's see how inside a web server or inside an application server, how things work. Okay, so I'm going to one website, for example, example.com. Now what happens between a few seconds, I get the page back, right? So the first thing which happens is the data packets, which on the user's computer, when the user types in the request and hits enter, it creates the data packets. The browser creates the data packets, which has typically three parts: the header, that is the target address, the body of the request, and the footer, that is the source address. Now here the source address is the browser from where the request was generated, and the header is example.com. Now the browser connects to the web server, and in the very next thing which happens, I have taken a secured web server as an example, okay, HTTPS. The very next thing that happens is an SSL handshake. It is a 5-step independent process which happens between the browser and the web server, and it happens in split second. I'll quickly tell what are those 5 steps. Is named in this way. First, the browser says hello, then the server sends hello, and the server sends a public key back to the browser. A browser creates a session key back to the server, and in the last step, the server decrypts the session key, creates a private key, and the remaining communication happens using that session key. Okay, the encryption and decryption actually happens only once. Now, sorry, the SSL handshake is a big topic, so I did not go to the details of it. But after the SSL handshake is over, so the browser and web server sets up the session key, which is used for all future and all the future traffic that will happen. Those data packets loaded with the encryption key. Now, if you notice, the data packet has actually increased in size because this is now scrambled by encryption. Okay, so the header still is the target address, that's the web server, then the body of the content, and the footer, which is the user's computer. Now, none of these three parts are readable anymore. It has become scrambled based by using the session key which we created during the SSL handshake. Now this scrambled data packet now reaches the load balancer or the web server after passing through the network components, following the shortest path directions provided by the DNS servers. Since it is an encrypted packet, it is received at port 443 of the load balancer, and either the SSL offloading happens at that layer, and offloading typically means it's decrypted, or the SSL offloading does not happen at the load balancer. It is passed on as is to the next layer, which is the web server layer, and the SSL offloading happens at the web server. Okay, so after the offloading happens, the actual data packets are extracted by the web server, and the web server then analyzes the information inside the packet, typically in the body part, whatever is there in the body part of the data packet, and it decides whether it can serve the response back to the user, or does it need to forward that request to the application server at the next layer. So based on what it decides, so the data packets are received at the predefined port of the application server. How does the web server know about this particular port? Because it is written in the configuration of the web server in which port of which application server the request will jump. So now at that data packet, at that application server, the data packets are processed, whatever based on the business logic, whatever is defined in the business application. It frames the response packet, and it is sent back to the web server at the same port, number 443, because it is still an encrypted, it is still considered as an encrypted package. Now the web server onloads the SSL on that. Now, if you remember, in previously it had offloaded the SSL, so it means that it had decrypted the data. Now it is its job to re-encrypt the data. So it uses the same session ID, session key, which it had created initially, and re-encrypts the data and passes it back to the load balancer. The load balancer, okay, now if the web server does not do the SSL onloading, if initially the SSL offloading had been done by the load balancer, then in the return journey, the onloading will happen at the load balancer level. So the load balancer encrypts the data packets and send it back to the user's browser. Now the browser receives that packet which are encrypted, and it is in scrambled way, in a scrambled condition. Now it uses the same SSL session key to decrypt the data, but in this case, if you notice, the size of the packet is bigger, because typically the response which comes back from the server would be bigger in size than the request which has gone from the browser. But another important thing is the header and footer has got reversed. Now the footer is the source of the web server, source from where it came, and the header is the target address, that is the user's computer. So after decryption, the end result, which is the body of the content, the body of the request, is becomes visible on the browser, or becomes visible on the client application which the user was using. For example, I gave the example of HPSM, right? So we get to see the ticket details. So after all this happens in the background, we get to see the data back, but it happens in a few seconds, and that's why we don't get to understand or realize what is happening, or the layers which are happening behind it. Okay, so can I proceed, or if you have any questions at this, we can.
Dave, I have one.
Yes.
Whenever this DOS attack happens, right?
Yeah,
so
I was
part
coming
of
to
the
that. Okay.
Okay, then.
Yeah. So, the very next topic is the cyber threats, which are very much associated to middleware. There are typically 4 or 5 types of cyber attacks for which middleware can be directly responsible. One is DOS or DDoS. Full form is denial of service or distributed denial of service. The other one is cross-site scripting. The third one is SQL injection. Fourth one is website spoofing. And weak cipher exploits in browsers. It's a very new one actually. It's typically came into picture from the year 2015. Now, all of these, literally all of these are due to poor coding of the web application or due to incorrect configuration on the web server or application servers. I'll talk about DOS or DDoS here because for the time shortage. Now, as the name suggests, it's a denial of service. Now, what is a service? For example, I have example www.example.com and I sell flowers from there. All right. If I am not able to reach, or rather, if a valid user is not able to reach my website for whatever reason, that's a denial of service to that user. Now, this denial of the website to the user can be created. Okay, and how is it done? Balaji, was that your question?
Exactly, yeah.
Yeah. Let me go to a drawing board. It will be easy for me to explain. All right, so this is my server, and this is my user. Okay, don't go by my drawing. So this user accesses this particular server and gets the response back. My service is working fine, right? Now imagine in this particular web server, I have given a field where the user can type in the name of a flower and try to search whether that flower is available in the stock or not. Okay. And by mistake, instead of giving, the web developer, by mistake, instead of mentioning that box as a text field, instead of mentioning that as a text box, he has mentioned that as a text field. Technically, it means that you can enter unlimited number of characters in that box. Okay. So I want to damage your service. So whoever is running this particular website, I want to damage their reputation. So what I do is I go and I have found out this loophole. So what I do typically, I will go and in the search box, I'll probably enter a few thousand gibberish characters because it's a text box. It doesn't have or does not restrict the limit of characters I can enter. And after entering that number of characters, I'll press search. So what will the web server do? Web server will receive the request and then pass it on to the application server sitting behind it. And the application server, based on the search logic, it will try to search each and every of those gibberish characters or gibberish words in its database. And definitely it will take a lot of time. By that time, I go to a second browser, I open another browser and do the same thing. Or I'll open another from another computer, I'll do the same thing. So the web server, whose only job is to receive the request, is still waiting for the application server to serve the response back to him. And the request number 1 is not finished, the request number 10 comes in, right? So when now I am a valid user, I go to that same website and I type in Lotus and I hit enter. The web server passes my request back to the application server, but the application server is still busy with the previous 10 requests. And of course, those gibberish requests will take a hell lot of time because the keywords does not exist. So it will keep searching the entire database word by word or character by character, and it will return nothing. So until and unless those 10 requests are completed, my request will be waiting. So I am being denied of service, and after a certain period of time, that page will simply time out. So I have been denied of my service. That's what happens in a denial of service. Now imagine that kind of attack being simulated from not one but hundreds of computers together. So that's why it's called distributed denial of service. So none of the valid users of that website will be able to open the page or do anything inside the page, even they are able to open it, because some invalid manipulated requests are running in the background, and the application server is not free to serve the next response back to the next valid user. So this is how the DDoS or DOS attacks happen.
Thank you, Dave.
And it can be, and as I said, it always happens because of poor coding and misconfiguration in the middleware layer. All these this kind of attacks. So how in this particular case, for example, if the web developer had mentioned the text box as a text box instead of a text field, it would have not allowed a malicious hacker to enter n number of characters, I mean limitless number of characters, and then press the search button. At the that particular layer, it would have rejected. Okay, so the malformed request would not have gone back to that until that application server at all. Right? This is one. This is one way that could have been protected. The second way is, on the application server, we can actually define some timeout value. Like if a web request is not completed, or if a page does not load at a certain period of time after a certain valid number of seconds, it will be considered as an invalid request. The browser will reject it and accept the next valid request. Okay, so if these two things had been done, this DOS attack or DDoS attack would never have happened. But still it happens because there are hundreds of web pages. Even in one page which is inside another page, this kind of gap is there, this kind of loophole is there. It can be exploited in the same fashion. Okay, did I explain what you were looking for, Balaji?
Yeah, Dave. Thank you for that.
Okay, so let's go back. So cross-site scripting is a typical one where you have a valid-looking website, and you click on a button, and actually behind something else is written on that button. But when you click on a button, it takes you to a different site, completely different page. So, and it can be a malicious page which can inject a kind of malicious code into your browser. So those are examples of cross-site scripting. SQL injection is done by entering SQL queries, which for example, in a typical example is in a login box where you are supposed to put in your login ID. Instead of putting a login ID, you are entering a SQL query, and the query is formatted in such a way that it will do some damage on the table where the query is supposed to land up, like dropping a table or dropping a column or something like that. So those are SQL injection, and again it is due to poor coding. The SQL injection can easily be controlled by using proper validation methods at the front-end layer itself. Website spoofing is where illegitimate websites are hidden in the name of legitimate websites, and the moment you enter them, boom, you're caught. Or your website asks for sensitive information, and the place where you are entering them actually takes you not to that particular website's backend, but to some other malicious website's backend. Those are website spoofing. Weak cipher exploits is again something related typically with the middleware. These web servers, as I mentioned, they are one of the main job is to do the encryption and decryption during the SSL handshake. So if the ciphers used at that at the browser from where the request is coming is a weak one. Okay, so when the info comes from the browser, the web server uses the public key and the info coming from the browser to create the session key. So if the browser is using a weak cipher algorithm, so the session key, the info which is used for creating the session key, will carry those weak ciphers, and the end product, the end session key, will be a weak one. So that's how weak cipher exploits in browser hits a lot valid users, because in this particular case, if the browsers keep the latest version of the browsers, updated versions of the browsers on the laptop, this can be controlled. But also, if the web application or the web server, while coding the web application, you can create a logic where you can check the browser's cipher strength, and if the cipher strength is below a certain threshold, that request can be rejected. In that way, this particular type of attacks can be controlled, right? So that almost brings to the end of my presentation, and you might be wondering where this middleware is going and what's the future of it. So IBM puts it very nicely. Once again, I borrowed the following lines from IBM. They have put the future of middleware as per the nature or function in 4 quadrants. We have application platform, business process management, cloud integration, and DevOps. These are the 4 quadrants where middleware is going to be and remain in future, right? So, and as you all know, everything is code nowadays. So that's exactly where middleware fits in, right? So that is the end of today's presentation, and if guys you have questions, you can shoot. Otherwise, you can close.
Anyone has any question, team? Okay, Dave, so it was a very useful session and you articulated it very well. We appreciate all your work in preparing this tech talk for all of us. It is much appreciated.
Thank you, Dave. It was very informative as well.
Thank you, Manu. You're welcome.
Yeah, thank you, Dave.
Yep. Bye-bye.
Session was very
Bye-bye,
interesting.
team.
Thanks,
Take
Dave.
care.
Bye.